Let's discuss a very interesting problem, add two numbers. So in this tutorial, we first understand the problem statement, then we discuss the approach, and finally we will write its Java code. So let's start with the problem statement. So in this problem, we have given two non-empty linked lists representing two non-negative integers, and the digits are stored in reverse order, and each of their nodes contain a single digits. So these two are very important points. So first, the digits are stored in reverse order, and second one is each of their nodes contains a single digits. So we have to write a code to add the two numbers and return the sum as a linked list. For this problem, we may assume the two numbers do not contain any leading zero except the zero itself. So let's understand this problem statement through examples. So in the first example, so given these two lists, so actually the original number is 342 and 465. So the digits are stored in reverse order. That's why the 2 comes first, then 4, then 3. Similarly for this list. Now what we have to do is we have to traverse both the list and add the numbers uh, present in their node. So first we add these two numbers, so the result is 7. Then we add these two numbers, so the result is 10. So we write 0 and 1 is carry, and then we add the number present in these nodes, which is 7, and add 1 which is carry. So now it is add. So now it is very straightforward, and it is the easier version of the problem, add two numbers 2. Now let's modify the input. So instead of 3, what if the number is 6? So let's forget 3 and assume it is 6. Now let's start adding it again. So when we add these two numbers, it is 7, then 10, so 0 and 1 is carry. 6 plus 4, 10, and when we add 1, it is 11 and 1 is carry, and then we add 1. So the result linked list is 7, 0, 1 and 1. So we have to consider this carry as well. So this is the problem statement. And now this second part is, now let's discuss the approach. So let's discuss how we can approach this problem. We have understood the problem statement. Let's visualize the approach. The easiest approach is to traverse both the lists, take their node values one by one if it is not empty, and add their values. What if the addition is greater than 9? In that case, we have to set the carry as well, and the initial value of carry is 0. So when we add the sum, so the sum will be the value of node 1, the value of this node plus carry. So the initial value is 0. It means 0 plus 2 plus 5, which is 7. So let me write this statement as well. We have added the value of the first nodes. Let's move to the pointer to the next node. So where the sum will be this 4 plus 6, and the carry is 0. So we add 0, and here we get 10. So it means the sum is greater than 9. So we have to set the carry. So carry will be 1, and the node value will be so the node value will always be sum modulus 10, so that the node always contains a single digit. So we add 0 here. Now let's move the pointer again to the next node, and here we add the values present at this node. So the sum will be 3 plus 4 and also 1 carry. So now the sum will be 8, and we add this value. So the sum of these node values will be 8, including 1, which is carry. So to store the result, we need a list. So you can say a result list where we compute the sum of each node and store them in this result list, and every list has the head pointer. So let's take declare one dummy node. So let's it in data part, let's put 0. You can keep -1 or any value, and initially let's say head pointer will point to this node, and also one result pointer will points to this node. So why these two pointers? What's their purpose? So every list has the head pointer. So head pointer will points to the first node, and this result list. So this pointer will keep moving while we adding the values in this list. So for example, when we add the value of these two nodes 2 and so the result we get is 7. So we create one node, and in data part we add 7, and this part will points to the address of next node. So we move this result pointer from this point to this node. So now the result pointer points to the address of this node, and head pointer remain as it is. So at the end, when the traversal of both the list is done, when we form the result list, we return the reference of head pointer, as head pointer points to the address of first node, and this is the dummy node. So we return head dot next, which will points to the address of this node. Now the next two nodes are 6 and 4. So the result we get is 0, and why it is 0 I have already explained. So now in next, so result pointer will now points to this address. So it moves from now previously it points to the address of this node. When we added this node, now it points to the address of this node. And next, when we add 3 plus 4 plus 1 carry, it is 8. So let's add one node whose value is 8, and now it points to null, and result pointer will points to the address of this node. Now it is clear we cannot return the reference of this result pointer, because if we return the reference, it will points to the address of this node, we get the wrong result. So the result we need is 708. So what we do is we return the reference of head.next, which will points to the address of this node, and using this node we can easily traverse this list, where we get the result first 7, then 0, then 8. So this is what we have done. Now let's understand the code. So we have declared so one head pointer and one result list, where we store the sum of the node values, and then two variables, which is carry and sum. So what we traverse both the list. So we run a loop while the list 1 is not null, or list 2 is not null, or carry is not equal to 0. Why this condition? So you will understand shortly. Then in each iteration, initialize the value of sum to 0. If first, so if the node value of, if linked list 1, so let's say list 1 is not null, so take its value, so 2, and add it to the sum variable and move its pointer to the next node. Similarly for list 2, take the node value if it is not null, and after adding the value to the sum variable, move to the next pointer, add the value. So from there we get the sum of the first node plus sum of the second node, and then we are adding the carry. If the value of sum, so here to get the carry, we are dividing the sum with 10. So basically, so if we divide 9 by 10, we get 0. But if we divide 10 by 10, we get 1. Similarly, if we divide 11 by 10, we get 1. So we are computing the, so we are computing the value of carry, and then we are creating a new node, and its value will be sum modulus 10, which I have already explained, and then we move the result pointer to the next node. And what is the purpose of carry is not equal to 0? Now let's suppose the value here is 6. So from here we get 0. Now it is a straightforward till this point. Now let's add 6 plus 4, which is 10, and then add 1. So when we add these two values, we get 1 as a carry. So here we get 1 and we get 1 carry. Now the list 1 is null, list 2 is null, but carry is not equal to 0. So we need one more node where its value is 1. So that's why this condition. So if this is the case, so it will be 7, then 0, then 1, and then 1. So for one more node we need to create, so until the carry is not equal to 0, we need to create one more node and put this new value. So that's why this third condition. And after the complete traversal, we return the reference of head.next, which points to the address of this node. So this is the approach to solve this problem. Now let's talk about its time complexity. So we are traversing both the lists. So the time complexity will be the maximum of m or n, where m is the size of the first list, n is the size of the second list. So it is the maximum of m comma n. So that's it for this video tutorial. For more such programming videos, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.